Hello, hello, hello! We are in Unit 2B and we're going to be talking about chemical reactions and equations over the next couple of sections. In this section you will learn what a chemical reaction is, and you will also be able to identify different types of chemical reactions. So a chemical reaction is also known as a chemical change, and it's when substances will break their bonds, rearrange, and form new substances with new bonds. You can see in the diagram below that we have hydrogen molecules, which are going to break apart, an oxygen molecule, which will break apart, and then they will rearrange to make two separate water molecules. So sometimes it's hard to determine the difference between a physical and a chemical change. On this page, I'm providing a list of observations or indicators to identify that chemical change or chemical reaction. The first one is a color change. We then have an odor change. Think of the smells that come off of a fire. Gas production. And so you can see over here that there are bubbles forming on the inside of that test tube to signify that gas is being produced. We have precipitate formation. This is an example of a precipitate. This yellow insoluble solid is being formed when two aqueous solutions have reacted with one another. And the last one would be temperature change. And we have two types of temperature change: exothermic reactions, which would mean that heat is being released out into the surroundings. Thus, we would see that the temperature would increase. And once again, a fire would help us with that idea. And then endothermic reactions. With this case, the reactants are absorbing heat and the temperature of the surroundings would actually go down. And lastly, we've got the evolution of light, and that's usually happening when heat is being given off as well. So chemical equations are the sentences of chemistry, and it is a way for us to show a chemical reaction using chemical formulas and other symbols. If we take a look at the example on this page, you will notice this chemical equation has an arrow in it. That arrow is representative of a yield sign, and what it does is it separates the starting substances, which are called the reactants, in this case sodium chloride and silver nitrate, with the new substances being formed, which are called the products, in this case silver chloride and sodium nitrate. Notice in the chemical equation that sometimes physical states will be added, and there are some symbols that you need to know. The S stands for solid, the G stands for gas, L stands for liquid, and AQ stands for aqueous, which means dissolved in water. Now there are other symbols that you can put within this chemical equation, but we're going to keep it pretty basic at this point. So on this page I have an example of a word equation, and then I have translated that into a formula equation or a chemical equation. And then down at the bottom I have just a kind of a visual of the atoms and how they are rearranging themselves. In this case, magnesium, which is a metal, so that is solid, will react with aqueous hydrochloric acid to produce aqueous magnesium chloride and hydrogen gas. You'll notice in this reaction that there is a 2 in front of the hydrochloric acid. We will talk about the importance of that in a few minutes. So when writing our chemical equations, it's super important that you're able to write a correct chemical formula. So make sure that you're really good with section 2.2. You want to recognize the words and is mixed with or reacts with so that you can add the plus when necessary. That plus is going to always separate several substances, either on the reactant side or the product side. And if you see the words yield, produces, forms, then you're going to use the arrow. Remember that the arrow separates the reactants from the products. Lastly, I want you to remember this mnemonic Brinkelhoff. It will help you with the 7 diatomic elements that have to have a subject of 2 in their chemical formula when written by themselves. And you can see that down here at the bottom. And we'll work more with that in a few minutes. So we're going to do this practice problem, and all we're doing in this is translating the words into chemical formulas. This is a review of section 2.2. So we have aluminum metal, and we know that that's going to be Al, is reacted with, and so we're going to go ahead and add that plus, hydrochloric acid. And so we're going to go back to the rules for acids and write HCl. To form, and that's going to be our arrow, aluminum chloride. Now aluminum chloride is an ionic compound, so I'm going to go ahead and do my symbols of Al plus 3, and chloride is Cl minus 1, and so that's going to provide me with a chemical formula of AlCl3 when neutralized. We've got the and, which is going to be the plus, and then hydrogen gas. Remember that hydrogen is part of Brinkelhoff. And so that is one of the elements that when by themselves will get a subscript of 2. It's a diatomic element. All right, in our second example, we're going to begin with copper 2 nitrate. That is an ionic compound, so I do need to translate that into a chemical formula. I'm going to start off with the copper, which is Cu, has a Roman numeral of 2, so it's a plus 2 charge. And the nitrate tells me it's a polyatomic ion. I'm going to look up its symbol and charge and do my crisscross, and that's going to start me off with my first reactant. The next problem, or the next formula I have is sodium hydroxide. Notice there was an and there, so I've already put the plus into the equation. Sodium hydroxide is also an ionic compound. Sodium is Na plus 1, and hydroxide is OH minus 1. Both of those charges add up to 0, and so I will just bring them together in a 1-to-1 ratio down here. I have the word form, which means I'm going to add my yield sign, the arrow, and the next formula that I see is copper 2 hydroxide. So I will go ahead and work that out as well. I've got Cu plus 2, hydroxide is OH minus 1. I'll do my crisscross here, and we will end up getting this formula, which is the first of our products. We've got an and, so I'm going to add the plus. And the last one is sodium nitrate. So Na plus 1, nitrate is NO3 minus 1, and those will come together in a 1-to-1 ratio. And so this is our second equation. So there are 5 types of chemical reactions that you will need to identify upon sight. I'm going to go ahead and list them for you, and then in the next few slides we'll talk about some identifying characteristics of each. This first one is a synthesis. The second one is a decomposition. The third is a single replacement, which we use SR as an abbreviation. The fourth one is a double replacement, DR. And the last one is an example of a combustion reaction. So our first type of reaction is the synthesis reaction. It's known as a combination as well. And it's when 2 or more substances combine to form a single substance. The identifying factor here is that there will be a single product on the right-hand side. And the substances that combine can either be 2 elements, such as copper and sulfur forming copper sulfide, or it could be more complex and 2 compounds coming together to form a single substance. Remember, the identifying factor here, once again, is that single substance that's being produced on the product side. It doesn't really matter what's on the reactant side. Here's just a quick little cartoon to show what a synthesis reaction really is. It's when 2 things are combined into one. The decomposition reaction is a reverse of the synthesis reaction or combination. It's when one substance breaks apart into 2 or more simpler substances. It does require energy in the form of heat, light, or electricity to get started. The key identifying factor here is the single reactant on the left-hand side. That single reactant is going to be a compound, and that compound will either break down into elements or it can break down into smaller, simpler substances. And you can see with this first example, calcium sulfide breaks down into the two elements that make it up, whereas hydrogen peroxide breaks down into simpler substances, a compound, and a diatomic element, which is sometimes called a compound as well. And here's a quick cartoon to show the loving couple on the left, and then they separate and walk away from each other. They're two separate pieces on the right. A single replacement reaction is when a more reactive element replaces a less reactive element in a compound. In this diagram, C is the more reactive element, and what it's going to do is replace A. What that means is A is going to come out by itself, and we will then get a new compound being formed, which is going to be CB. In the example on the bottom, you can see that in this case, the potassium is going to replace the silver, and we end up getting Ki as the new compound and Ag as the element that comes out of the original compound. The key identifying factor here is looking for a reaction that's going to have a compound and an element on both sides. And it doesn't have to be in this particular order. It could be an element and a compound reacting to form an element and a compound. You just have to have an element and a compound on both sides. Here's a cute cartoon to show the single replacement reaction. You can see right here that this guy is going to replace the boyfriend, and the boyfriend will then be all by himself, and the new couple has formed. Joe and Mary are together. A double replacement reaction is when the positive ions of each aqueous compound replace each other. In this case right here, the black and the blue spheres will replace each other. And as they do that, we form the new compounds that you see on the right. If we look at a real example, we've got the potassium and the silver ion that are just going to switch places with each other. So when potassium switches with silver, we make KNO3, potassium nitrate. When silver switches with the potassium, we end up getting AgI, which is silver iodide. The key identifying factor here is that on both sides we are going to see compounds, and on the left side they should be aqueous. If not both, at least one will be aqueous, dissolved in water, and that's important because the ions cannot swap places with each other without that liquid medium. And another cute cartoon to show the double replacement reaction, and you can see basically what's happening here is that the men are going to swap places with each other, and we end up getting two new couples or compounds if we're talking about a reaction. So here we have a real-life example. We've got Justin Bieber and Selena Gomez, and at one point in time Taylor Lautner and Taylor Swift. And later down the line you can see that the boys have swapped places with each other, and we end up getting Taylor Lautner with Selena Gomez and Justin Bieber and Taylor Swift. And so you can see two new couples or two new substances have formed. Our last type of reaction is a combustion reaction, and that is where an element or a compound will burn or react with oxygen to form an oxide and also produce heat. In our example below, magnesium is burning in the presence of oxygen, and it's producing magnesium oxide. Now we said that it's also going to produce heat, and we can either write that off to the right, or we could actually use a symbol that would actually tell us how much heat is being released from the reaction. The second type of combustion reaction is one that we'll commonly see where hydrocarbons, that is a compound that consists of a hydrogen and a carbon, burning or combusting, meaning it's going to react with the elemental oxygen again, but to produce carbon dioxide and water. And those are the two products they will always form. It doesn't matter what kind of hydrocarbon is present. When it burns, it always produces the carbon dioxide and water. And of course, that heat as well. And the key identifying factor here is that oxygen. If you can see an oxygen as a reactant on the left-hand side, you will know that you're working with a combustion. Don't get confused with the fact of this also being identified as a synthesis, a single substance being produced. So some reactions can actually be classified in more than one category.